Hi students, welcome to my YouTube channel SADHIK Physics. We already started ray optics. In that we already discussed reflection and refraction and reflection through the spherical mirrors and plane mirrors also. Now today we will discuss one more new topic, that is ray optics. In that prism we will discuss now, right? Prism is a very important concept now. So which you can see frequently the questions in all the competitive examinations. And in this video, I can guarantee that if any prism question now comes in the examination now, you can do immediately, easily, so without any confusion on this, right? So this may be like a one small video, so but it will give a clear information regarding the prism, so that you can solve any type of problems. So from regarding the prism now, right? So let us see, therefore I will give some 4 formulas now. So that 4 formulas is enough, any type of questions now you can solve it for the prism now, right? So let us see what are that 4 formulas now, how to solve the problems related to the prism now, right? So let us come to our video. So ray optics in that prism. Now first of all let us see the prism. So prism means what? You might have seen the prism. I'll show you one image related to the prism. No, so here there is a 2 refracting surfaces are there. These are the 2 refracting surface. So incline at an angle onto this, and this it will be the base of the prism. Now this it will be a base of a prism. 2 refracting surfaces inclined at an angle. Now this angle, so we will call it as like a angle of prism, and A it can be written as like a angle of prism. Sometimes, most of the times, no, so they will call this angle of prism is also called as like a refracting angle of prism, a refracting angle of prism, right? So don't confuse, most of the students know, they will confuse that refracting angle means they will think that it is a angle of refraction now. Really it is not the angle of refraction. Refracting angle or refracting angle of prism means is nothing but a angle of prism. This is the first confusion, no, most of the students will get confused in this, right? So here refracting angle means not an angle of refraction, is an angle of prism now, right? So here in this one now, therefore on this prism now we are going to incident one light ray. This light ray should be compulsory monochromatic, right? Why monochromatic? Monochromatic means what? Single colored light ray, like our yellow color light ray or a red color light ray or a blue color light ray, or single wavelength or single frequency. Monochromatic, not white light. White light is the combination of so many colors, no, so that we can call it as like a polychromatic. So right here we are going to discuss so only monochromatic. Later on we will discuss dispersion, no, so polychromatic, no. Here one single color light ray we are going to incident. Why? Also we will study at the end of this this video, no, right? So now what you have to do, this is your incident ray. So incident ray means compulsory you have to draw one compulsory normal here, no. This is your first normal, clear? So this it will be your angle of incidence. Now it is traveling from air or vacuum, no, right? Therefore this is your rarer medium and entering into some optically denser medium now. So when a light ray is entering into the denser medium, what you can observe now? You can observe that so the light ray will bend toward the normal. Therefore it is bending toward the normal now. So like this it will be your refracted ray. This is your incident ray. This is your refracted ray. It is making an angle of refraction. No, R1 will be your first angle of refraction. Now it will go in the straight line. No, then what will happen now? Again going to incident onto the second surface. No, so here this is your normal 2. Now the light ray is traveling from where now? From the denser medium to again rarer medium now. When it is entering into the rarer medium, what will happen now? It will bend away from the normal now, right? So this light ray, what will happen now? It will bend away from the normal here. So this angle we'll call it as like a angle of emergence. No, this angle is nothing but a angle of second refraction. No, right? So this is here two normals are making an angle some theta. Clear? So in this way you need to draw the ray diagrams. No, so also sometimes you can feel that. So this is your prism is made up of a glass, maybe placed inside the some liquid. No, at that time if you have to see the refractive indices, and you have to decide which is optically denser, optically rarer, then you have to draw the ray diagrams. Clear? Now, so one more observation you can see it. This emergent ray is always bend toward the base of the prism. This is your base of the prism. So you can observe that this emergent ray is this emergent ray is always bend toward the base of a prism. Clear? So that means this prism is placed in a rarer medium, then the emergent ray is always bent toward the base of the prism. And one more important observation you can see it now. So here this is your light ray. So this light ray, so what happens now? This light ray should, if this prism was not there, it would have gone like this. But with this prism, finally this ray is come here. So therefore this much amount of angle of deviation was taken place now. Clear? So this is your angle of deviation. That means this is your incident ray, this much is getting deviated here now, right? So this is your angle of deviation now, angle of prism, angle of incidence, angle of emergence, R1, R2, this all this. Clear? So then we will have some relation between these angles. You can use this triangle and this triangle. This triangle also you can use it, triangle and quadrilateral. So you can derive it, the relations of this between these angles. But here I am not going to derive it. So I will give directly the formulas. So what are these angles relation between them? So you see here, you can remember this one. For any type of prism, these angles, this formula is applicable. So this angle of prism, it will be equal to sum of this refracting angle of refraction. So R1 and R2. And exterior angles, therefore angle of incidence plus angle of emergence is equals to, so angle of prism plus angle of deviation. This is a very important relation, very very important formulas or relation between the angles. Clear? And these two formulas you need to remember compulsory. If you really practice, then you will remember. So how you got it? Just you observe some of the angles in a triangle is 180 degree, some of the angles in a quadrilateral is 360 degree. You can use that concept, you can derive easily onto this. Clear? And one more important formula, that is nothing but a Snell's law. So you need to apply the Snell's law here. So at different points, here we will apply the Snell's law here we will apply the Snell's law. So if you apply the Snell's law here, what you will get it now? So how to apply the Snell's law? So please go through my refraction video, then you can understand very easily. So we will apply the Snell's law here. How to apply? So you have to travel in this medium, that is it is traveling in the air. So air means refractive index is 1 into, it is making an angle of this one, that is sin I, it will be equal to entering into the denser medium n into sin R1. So this formula, and also apply the Snell's law here, right? So how to apply the Snell's law here? Light ray is traveling from denser medium, therefore denser medium means, so it is traveling in this medium n into sin, it is making R2, sin R2, and entering into the rarer medium 1 air or vacuum. If any other medium is there, then you have to use the refractive index of that medium into sin E. That's all. Really, if you already, these all are simple things, extra learning is only this one onto this one. So these all are already know it. So applying the Snell's law 1, 2, 3, 4, only that's 4 formulas is enough to solve any type of problem related to the prism. Clear? Right? So therefore let us see how to apply different situations. So let us see one by one situation in this one. So now see, only the names are different onto this. different way of angle of incidence, no, angle of refraction, like that. Clear? And this is your prism, no, right? So sometimes they will call you, they will tell you that is normal incidence. Be careful, no. Therefore, here normal incidence. What is this normal incidence? No, these words only you need to understand. Normal incidence, grazing incidence, normal emergence, grazing emergence, like that. Clear? Normal incidence, remember that normal incidence means light ray is falling along the normal. So this is your normal, no. So therefore in this direction, no. So this is your normal. Clear? Right. So sorry, here, no. This is your normal. Therefore here along the normal incident ray is there, no. Incident ray along the normal means what will happen, no. Angle of incidence, it will be the 0. Angle R1, it will be also equal to 0. There is no refraction here, no. Therefore what will happen now, this light ray, it will go directly here, no. So it will fall R2. So then it may be goes out with this one. Clear? That's all. You know, normal incidence means this point you need to understand here now. Clear? So therefore you know that relations, no. A is equals to R1 plus R2. R1 is 0. So A is equals to R2. This R2 will be equal to nothing but A. Clear? So therefore here angle of deviation here, no. So I plus E is equals to A plus delta. So therefore here I is 0. So plus E we don't know, we want to calculate. A is nothing but A and it will be the delta here. Clear? So therefore here if you want to apply, you can apply the Snell's law here, no. So what is the Snell's law here now? So light ray is traveling in the denser medium, refractive index is n into sin R2 is equals to 1 into sin E. Clear? So therefore n into sin R2 is nothing but A is equals to sin E. That implies E is equals to sin inverse of. So therefore sin A into therefore n into sin A. So these all are just only mathematical, no, but here only you should understand this is your incident and angle of refraction, this one. Then substitute here, no, substitute here. Angle of deviation you can calculate in this way. Clear? Just substitute E value here, no, just you can substitute, no, you can get your answer. Clear? So normal incidence means like this you need to understand. Clear? Now we can apply one more thing, one more concept, no, that is grazing incidence. Grazing incidence. So what is this grazing incidence? No, name only it is important, no. So you need to understand here. So this is your therefore here this is your prism, it is A, this is your base of the prism now. Clear? Angle of prism here. Now what happens now? Grazing incidence now. Therefore the incident ray, therefore it is coming along the surface of this. This is your incident ray. Clear? So along the surface of this one is incidenting, no, that is called grazing incidence, no, and this is your normal. So normal 1. So this should be your 90 degree. Angle of incidence is nothing but 90 degree. So angle of incidence is 90 degree compulsory. Light ray is it's entering into the denser medium, no. So denser medium means what will happen now? It will bend toward the normal here, no. So it is normal here. So this should be compulsory. R1 should be equal to the critical angle. Clear? Now maybe it is incident here, no. This is your R2. Maybe it will go out onto this. This is your angle of emergence. This is called like a grazing incidence, no. Right? So again you can apply this one, no. A is equals to R1 plus R2. R1 is nothing but a critical angle. Critical angle formula already you know it, no. Sin C is equals to 1 by n. Clear? So then you can use whatever your formulas, no. A is equals to critical angle plus R2. Clear? So therefore you can apply the Snell's law here, you can apply the Snell's law here, you can apply the angle of incidence plus angle of emergence is equals to A plus angle of deviation. Angle of incidence you got it as 90 degree, angle of emergence you need to calculate it now. So therefore here how to calculate it now, again the same, apply the Snell's law here now, n into sin R2 is equals to therefore 1 into sin E. N value you can write down by sin A or the sin C, so that C value is nothing but sin R1 now. Clear? N is equals to, so n is equals to 1 by sin C, that is nothing but 1 by sin R1. Clear? These all are the small informations, no? So this will get clarity if you really see my refraction video on this. So substitute here now, what you will get it now? So sin E, so sin E is equals to sin R1, n value is nothing but 1 by sin R2, sin R2 divided by sin R1, E is equals to sin inverse of, so sin R2 by sin R1. R1 can be written as like a C. E I got it now, A I don't, I know it now. Angle of deviation, I value is already 90 degree here now. This is 90 degree, E value you can substitute from here now. Angle of prism is already given now. Then you can calculate the angle of deviation. Clear? So as per given questions, no, you can do it, no. So no need to remember all these one, no. Just to remember that 4 formulas apply. Grazing incidence means what? Normal incidence. That's all. Clear? Sometimes they will ask you grazing emergence and grazing right, normal emergence, no, also they may ask you, right. So suppose one concept I will discuss here, no. So one more thing here. So here this is your prism, so this is your angle of prism here, no. Now suppose here this is your one incident ray, right, this is your angle of incidence, no. Then suppose here, no, this is your refracted ray R1. Suppose here we can rewrite it as grazing emergence. This is called grazing emergence now. This emergence means compulsory it should be 90 degree. 90 degree means this R2 value is nothing but a critical angle. Again critical angle formula already you know it, no. Therefore sin C, so is equals to 1 by n. That's all. Apply here, no. So therefore here you know A is equals to R1 plus R2 and I plus E is equals to A plus delta. That's all. So apply the Snell's law here now. If you know this, you can calculate here now. These are the things, no, as per given questions, no, you can calculate it. This is what grazing emergence. Grazing emergence. Like that, normal emergence is also is there, no. What is this normal emergence, no? So normal emergence means what? Suppose this is your prism here, no. This is your prism. So this is your A, right. So therefore here this is your incident, no. So this is your angle of incidence now. Now the light ray is going like this. So then it is falling along the normal, that means it is going out onto this. So this we can call it as like a normal emergence. Clear? So normal emergence. Normal emergence means what? It is coming out along the normal, no. Therefore angle R2 will be equal to 0. Angle emergence is also will be equal to 0. This is your angle of incidence, no. This is your angle of refraction here, no. Clear? So then again apply the same formulas, no. A is equals to R1 plus R2, I plus E is equals to A plus delta. That's all. Clear? A is equals to R1 plus R2. So you can use the formula, you can apply the Snell's law here, no. That is nothing but 1 into sin I is equals to n into sin R1. That's all. So as per given conditions, now what they are asking, you can solve very easily onto this. Clear? This is your normal emergence, no. Sometimes they will ask you like total internal reflection should take place onto this, right. So that means here you can rewrite it as this is your prism here, no? Clear? So therefore this is your angular prism, no? Therefore this is your incident ray and this is your angle of incidence, no? So this is your incident ray. Now what happens now? Here the light ray should go and it will be fall onto this one, no? This is your R1. Here it is undergoing like a total internal reflection here. Clear? Total internal reflection means what will happen now? So it is this R2 should be equal to or greater than critical angle. You understand? No? That means to undergo like this one now, A should be equal to R1 plus R2. Therefore R2 should be greater than the critical angle. Clear? So that means what you can get it now, angle of prism should be greater than R1 plus C. Clear? So therefore if it is angle of prism is this R1 plus C, if it is greater than this one, no, then it will be undergo like a total internal reflection onto this. Clear? Suppose what will be the maximum R1 can get it now? Maximum R1 means therefore if it goes on increasing, no? So therefore here therefore when angle of incidence is 90 degree, at that time it will be maximum. So therefore R value is maximum, that is nothing but a critical angle now. Therefore A value should be greater than R1 is also C plus C, therefore 2C. If it is angle of prism is greater than 2C, greater than 2 times of critical angle, no, for any angle of incidence, no, compulsory total internal reflection will takes place now. Here total internal reflection. Clear? For any angle of incidence. Therefore if this condition satisfies, so for any angle of incidence, no, angle of incidence, so total internal reflection will takes place after this. Clear? Right? So in this way you need to solve it, no, the problems. And one more important concept is there, that is minimum angle deviation. Now let us see. So most of the times, no, you can expect the question. So this is minimum angle deviation. Minimum angle deviation now. So what is this minimum angle deviation? At minimum angle deviation, what is going to happen now? Let us see. What is this minimum angle deviation experiment now? This is your angle of prism. So therefore this is your incident ray here, no, monochromatic light, no. This is your angle of incidence, no, you know already. Clear? So therefore here it is angle of incidence, no. So you try to change the angle of incidence and angle of deviation, no. So therefore if you really find different angle of incidence and different angle of deviation, no, this is your angle of deviation, angle of incidence, no. So if you draw the graph for this, so for different angles, no, so if you draw the graph it will be like this. So therefore here the deviation is minimum. Therefore deviation is minimum. At this point, therefore what you can write it now? Angle of incidence and angle of emergence is both are equal. Angle of incidence and angle of emergence both are equal. If both are equal now, therefore R1 and R2 also equal now. What does it conditions now? What does it says now? That means, so when it will takes place now? So if a refracted ray, this also important point, no, this is your refracted ray, so this angle R1 and this angle R2. If both are equal, means compulsory this should be parallel to this one, no, parallel to this base of the prism. That means in a minimum angle deviation, no, what you can see, refracted ray will be parallel to the base of the prism. Clear? So refracted ray, so will be parallel to the base of the prism. Clear? So that means then only it will be R1 and R2 are equal and I1 and I1 and E are equal now. This also they may ask you in the examination, no. So at what angle, at what something, no. So the refracted ray is parallel to the base of the prism means you have to study angle of minimum deviation. Clear? So therefore if both are equal now, what you can rewrite it now? A is equals to R1 plus R2. R1 and R2 are equal now, therefore it will be 2R1. that implies R1 is equals to A by 2. Clear? Now next one is I plus E. E also E is equals to A plus delta, that implies I and both are equal now. 2I is equals to A plus delta M, that implies I is equals to A plus delta M by 2. Clear? Now you can apply the Snell's law here, no? Snell's law here. So what you can write it now, Snell's law? Very simple one, no? So Snell's law, therefore 1 into sin I is equals to n into sin R1. So n is equals to sin I by sin R1. Sin I value is how much now? Sin of A plus dm by 2 by sin of A by 2. So this is your refractive index of the prism with respect to the air, so for a minimum angle deviation. Clear? So therefore, so sin I by sin R1 is equals to, so sin of A plus dm by 2 by sin of A by 2. Very important derivation, no? So even for your board examination, no? This formula is also very important, no? So for minimum angle deviation. Clear? Let us see some important applications, no, regarding this one. Clear? We will see. So here one more small thing you can observe it now in this graph. If you really take some 2 points, no, therefore suppose I will take some point here, no, here, and at the same angle of deviation, no, here. So that means suppose here angle of incidence is x, so angle of emergence is y. So therefore at this point it is exactly reverse. That means angle of incidence it will be equal to y, so angle of emergence it will be equal to x. So where angle of deviation is equal, no, in this way you can get the two reverse, right, reciprocality you can say it. Clear? So sometimes you can use this concept, no, to solve the problems. So mostly this it will be your most important formula. Clear? And in this one, no, one more derivation, no, you can rewrite it as, so this is your refractive index of the prism with respect to air. Suppose if it is kept inside the water, refractive index of the glass with respect to water. In any other liquid, no, you can use it. So therefore for minimum angle deviation, A plus delta m by 2 by sin of A by 2. Suppose what I will do, I will take a small angled prism. Small angled prism. So what is this small angled prism means what? Therefore angle of prism is very smaller. Therefore A value it will be equal to small. If it is A is small, so this also it will become like a small. So therefore here if theta is smaller, no, therefore sin A it is nearly equal to A. Clear? So therefore here you can rewrite it as n is equals to sin of, therefore A plus delta m by 2. So by 2 by A by 2. Can cancel here, no. So n into A is equals to A plus delta m. That implies delta m is equals to n minus 1 into A. That means here angle of deviation is directly proportional to the small angled prism, also directly proportional to the refractive index. That means angle of deviation, minimum deviation, no, is directly proportional to the refractive index. You know that refractive index is inversely proportional to the velocity, it is inversely proportional to the wavelength, no. Clear? Clear? So therefore it is directly proportional to the critical angle also. Therefore it is directly proportional to, so it is inversely proportional to the wavelength. That means what you can write it now, if red color is having greater wavelength compared to the blue color, so it is also inversely proportional onto this one, no. So therefore what you can write it now, angle of deviation for red color is less than angle of deviation for blue color. That means, so if different colors are there, angle of deviation it will be the different here. That's why if you send a polychromatic like different colors, no, so therefore blue color or violet color will be having more amount of deviation, so but red color it will be having least deviated after this. So that's why you cannot get the sharp image, no, if you are using polychromatic, no, so dispersion will take place now. Clear? So that's why we used throughout these experiments, no, we used only monochromatic light. Understand, no? Clear? So this also observation is important, and this formula is also slightly important. Okay, so this also will discuss in terms in the dispersion, no, concept, no, just remember this, right? So I think you got the clarity onto the prism and how to solve this different concept. Now only 4 things, that is A is equals to R1 plus R2, so I plus E is equals to A plus delta. So apply the Snell's law in the both the situations, and minimum angle deviation at that point, no, refracted ray will be always parallel to the base of the prism. These 5 points is enough to solve the problems related to the prism. Clear? Really, if you like it or if you really understand, please just like it and share this video. Now we will discuss some problems here, no. So let us see one problem related to this one, no. So if it is not visible, so just to try to concentrate on my words, right? Find out the deviation produced by the prism now. Clear? So here angle of prism is given, therefore here angle of prism is given as 60 degree. So angle of incidence mu1 is 1. So that is, this is kept in the air or vacuum, no, this is your air, and refractive index is also given now. Angle of deviation we have to calculate, no. Angle of deviation means what you should get it now. Right, angle of deviation means you should get it as you want, right? First I plus E is equals to A plus delta. In this one, what are there now? Angle of incidence is there 60 degree, angle of prism is there, so this is there, this is there, but we don't know, we don't know E. So that's all, we have to calculate the E. So how to calculate E now? Therefore, right? So therefore here how the ray it will takes place here, no, this ray it will passes here, no, bends here, no, this is your R1, right? So now so this it will be able to bend it here, no, clear, and this it will be your angle of deviation, clear. This is your R2. Now if you calculate R1, R2 also you can calculate it, no, very easily. So first let us calculate R1 now. How to calculate R1 now? Apply Snell's law. 1 into sin 60 is equals to root 3 into refractive index into sin R1. Clear? So sin 60 is nothing but a root 3 by 2 is equals to root 3 into sin R1. Root 3 cancel, 1 by 2. So this it will get it as 1 by 2. 1 by 2 means sin 30. Clear? So that means angle of first one, no, so angle of refraction, no, that is 30 degree. But I don't know R2. To find that, what we know the formula? A is equals to R1 plus R2. A is equals to given as 60 degree, R1 is 30, R2 also should be equal to 30 degree. Clear? Again we will apply the Snell's law here, no. So we will apply the Snell's law here so that we can get the angle of emergence, no. So here, so traveling from denser medium, root 3 into sin R2 is nothing but a 30 degree is equals to 1 into sin E. Clear? So sin 30 is nothing but a root 3 by 2 is equals to sin E. Root 3 by 2 means sin 60. So therefore angle of emergence, no, it will be equal to 60 degree. Clear? I got it. That's all. So here angle of incidence is how much, no? 60 degree. Angle of emergence is also 60 degree. Angle of prism is also 60 degree. Angle of deviation. Clear? So therefore this will get cancelled out, no? Angle of deviation will be equal to also 60 degree. Understood? Clear? So like this, no need to panic anything onto this. So very easily you can solve even IIT advanced level questions also you can solve very easily. Only 4 concepts, that's all. Clear? So next question. Now let us see. Okay. One side it is placed at different media, another side is placed at error vacuum. Why? Because refractive index is 1 here, no? Refractive index is root 2 here and root 3. Clear? So he is asking again, find out the deviation. No? So again the same story onto this. Okay, draw the ray diagram so that you can understand still clearly. So this is entering from rarer media to denser media, bend toward the normal now. Clear? So this is your normal. So it is entering from root 3 is greater and root 2 is rarer, therefore it will bend away from the normal. Why? Because this is your rarer medium. Clear? This it will be your angle of emergence, R2, R1. Again the same thing. So here, so we want angle of deviation means I plus E is equals to A plus delta. I already is given 75 degree. Clear? So I already know it now, 75 plus E, not A, I, it is A. I is given how much now? 60 plus E is equals to 75 plus delta. What I don't know? I don't know E. So we have to calculate E. To calculate E, R1 is required, R2 is required. To get R2, R1 is required. Apply the Snell's law here now. So 1 into sin 60, we will apply the Snell's law here. So is equals to root 3 into sin R1. Sin 60 is root 3 by 2. Just now we discussed now. R1 is equals to 30 degree. Clear? R1 I got it now. Therefore R2 I should write it now. A is equals to R1 plus R2. So here 75, 30 plus R2. R2 will be equal to 45 degree. Clear? Now I got R2. Again apply the Snell's law here now. Apply the Snell's law here now. So how to get it Snell's law here? So here traveling from denser medium, root 3 into sin 45, it will be equal to entering into root 2 into sin E. Clear? Now root 3 by root 2 is equals to root 2 into sin E. So taken here now, root 3 by 2. So sin E, that is nothing but a sin 60. So E value will be equal to 60 degree. Apply here. So therefore here 60 plus again also it is 60 is equals to 75 plus delta. So this is, if you take it now 15, so minus 15, so 15 means 45. So angle of deviation it will be equal to 45 degree. Clear? So in this way you can solve the problems. No need to panic, right? Sometimes students know this, that, there, no, they will get panic. No. So prism means easy concept. Clear? Now let us go for one more question now. Right? So a ray of light, okay, if you are not able to see, please concentrate on my words. Clear? A ray of light incident normally on the surface of a prism. Normal incidence, meaning that's all. So here surface of the prism, angle A is equal to 30 degree. Emergent ray is grazed to the opposite surface of the prism. So find the refractive index. Very important, very easy. So first of all you need to understand the question here, no? So this is your prism. Clear? So this is your A is given as 30 degree. So what it is given now? He gave a light rays incident normally, normal incidence. Normal incidence means what? Along the normal. There is no angle of incidence, 0. Angle R1 is also 0. Clear? So therefore now what is given now? It is, what it is telling now? If the emergent ray is grazed on the opposite surface of this, surface of the prism, therefore this light ray is going like this. That's all. You understand? No? So going this one means compulsory this is your R2 should be equal to the critical angle. So we know R2, what is R2 now? A is equals to R1 plus R2, R1 is 0, so R2 will be equal to 30 degree. This R2 is 30 degree means this should be critical angle here now. So we know, so critical angle means, okay, we can apply the Snell's law here also, no problem. So this should be compulsory 30 degree, right? Light ray is incident, therefore refractive index is n into sin 30, it will be equal to 1 into sin 90. Grazing emergence means 90 degree, that's all. So sin 30 n into sin 30 is nothing but 1 by 2, n by 2 is equals to 1, n is equals to 2. Refractive index is how much? No, 2 of this given prism. Clear? Here if you really don't know what is normal incidence, grazing emergence, no, that's all. This problem it will be very difficult one. So be careful. So you can do questions very easily. Now let us see here. Therefore, the refractive index of the prism is root 2. Okay, refractive index given. Angle of prism is also given. What is given? Let us see. Let us calculate it. No, refractive index is root 2. Angle of prism is 30 degree. One of the two refracting surface of the prism is made of mirror inward by silver coating. Okay. The beam of monochromatic light is entering the prism from one of the face and retraces after reflection from the silver. Find the angle of incidence. Okay. So what is given now? Very simple one now. See here. This is here. I think this question is asked in the NEET examination. No. So this is here angle of prism. No. Suppose here this is here silvered here. Clear? This is silvered. Now what happens now here? So here angle of incidence is there. No, this is here, right? So we have to calculate it. No. Now what happened now? A beam of monochromatic light is entering the prism from one surface and retrace its path. That means this it will go like this, incident here, no, and get reflected back, and it is coming back after this. So that means if it is going on incidence, coming back means compulsory this should undergo like a normal incidence onto this. So therefore here it is going like this, coming on to this one. No, normal emergence, no, angle of E it will be equal to 0, R2 also will be equal to 0. This will be your R1. Clear? So R2 is 0 means A value is equals to R1. No, therefore R1 is 30 degree because A is nothing but a 30 degree. Why? Because A is equals to R1 plus R2. Clear? Now apply the Snell's law. That's all. Apply the Snell's law here. No, this only we want to calculate it now. 1 into this is your root 2 refractive index. No, 1 into sin I is equals to root 2 into sin 30. Sin 30 is nothing but a sin I is equals to root 2 by 2, therefore 1 by root 2 sin 45. Therefore angle of incidence is nothing but a 45 degree will be your angle of incidence onto this. Clear? So I think this question is asked is one of your competitive examination. Clear? So now we will go for next question. Right. If it is not visible, no, just try to concentrate on my words. No, refractive index of the prism is root 2. Refracting angle is 60 degree. Right. Very good. So please, if you really, right, see what is this refracting angle. Most of the students know angle of refraction they will take it, no, R1 R2 or something they will take it out of this. But refracting angle means is nothing but a, right, those who see the intro video or starting video, no, they will understand. What is given? Refractive index is root 2. This refracting angle is nothing but a angle of prism. Find out the minimum deviation. Delta M is asking. Clear? So delta M, right? So here what you can write now, for minimum angle deviation, sine of A plus delta M by 2 by sine of A by 2. That's all. So apply root 2. Clear? So sine of this is 60 plus delta m by 2 by sine 30. Sine 30 is 1 by 2. Clear? So 1 by 2 taken here, no? So root 2 by 2. So sine of 60 plus delta m by 2. This is 1 by root 2. 1 by root 2 is nothing but a sine 45. Clear? So what you will get it now? Very simple question, no? So just mathematics, no? Therefore 60 plus delta m by 2 is equals to 45 degree. Clear? Taken here now 90. 60 plus delta m is equals to 90. That implies delta m is equals to 30 degree. Clear? In this way you need to solve the problems. Clear? So right now let us go for one more question, no? Right. So here an equilateral prism, equilateral, again one more word, equilateral triangle, equilateral prism means what? So angle of prism is nothing but a 60 degree, that's all. Equilateral prism provides least deviation, angle of minimum deviation is 46 degree in air. Find out the refractive index of unknown liquid in which same prism gives least deviation. This is with respect to air and this is with respect to angle of deviation with respect to liquid is nothing but a 30 degree. Clear? Now we want to calculate refractive index of the liquid. Clear? Minimum deviation they are asking on to this. So again the minimum deviation, what is the formula? So therefore here you can do the two things here, no? One is with respect to air, refractive index of the glass with respect to air, it will be equal to sine of 60 plus 46 by 2 by sine 30. Clear? Now therefore here sine of what you will get it now? So here 60, therefore 40, therefore here you can rewrite it as 100 and so 106 divided by 2 by sine 30. So 106 means sine 53 by sine 30. Clear? So you know sine 53, these angles, no? You know it, right? This is your 3, 4, 5. This is your 37. This is your 53. So sine 53 means 4 by 5. So what you can write it now? Refractive index of the glass with respect to air, it is nothing but a 4 by 5 by sine 30 is nothing but a 1 by 2. That implies, so here 8 by 5 8 by 5. This is your refractive index of the glass with respect to air. Now we will see this refractive index of glass with respect to liquid. With respect to liquid, what is given now? Therefore sine of 60 plus 30 divided by 2 by sine of 60 by 2. Clear? So this is here refractive index of the glass with respect to liquid means, so here you can write it as refractive index of the glass with respect to air by refractive index of the liquid with respect to air. Clear? Right? Now what you can write it now? This is your sine 45 by sine 30. Sine 45 is 1 by root 2, therefore 1 by 2. So therefore it is nothing but a, taken here now 2 by root 2, therefore root 2 will be here, right? So here you know refractive index of this one, no? Therefore 8 by 5. So therefore by refractive index of the liquid with respect to air, it is nothing but a root 2. That implies, therefore here refractive index of the liquid with respect to air is nothing but 8 by 5 root 2 will be your liquid. Right. Let us see this question. Ray of light passing through the prism of refractive index. Okay, given refractive index how much now? Root 2. Suffers minimum deviation. It is found that angle of incidence is double the angle of refraction with the prism. That means angle of incidence is nothing but 2 times of this R1. But a minimum deviation is there now. R1 will be equal to R2. That implies, so here R1 will be equal to A by 2. Clear? Understood? So substitute here now. Therefore angle of incidence is nothing but 2 into A by 2. That is angle of incidence is nothing but a refracting angle of the prism. Clear? Now we will apply the Snell's law here now. So therefore why? Because here what is asking now? Find out the angle of prism. So here it is root 2. Clear? Now it will go like this. Therefore here I, this is your R1. Clear? So now let us substitute here now. So what you will get it now? Here, so 1 into sine I is equals to n, that is nothing but a root 2 into sine R1. Clear? Sine I, we want A value. Find out the angle of prism. So sine I is nothing but a sine A is equals to root 2 into sine of R1 value is nothing but a by 2. Clear? Sine A, like a sine of 2 theta, you can write down 2 sine A by 2 cos A by 2 is equals to root 2 into sine of A by 2. This will get cancelled out onto this. So here, therefore, here cos of A by 2 is equals to root 2 by 2 is nothing but 1 by root 2. Clear? So therefore here cos 45, so therefore A is equals to 90 degree will be your answer. Clear? Right? Angle of prism is nothing but a 90 degree. Clear? So now we will go for one more question now. Right. So let us see, you know, if the minimum deviation is equal to angle of prism, find the refractive index. Okay. So what is given now? Here angle of minimum deviation is nothing but a angle of prism. Clear? So he is asking refractive index. Very simple one now. So minimum deviation, you know the formula, n into sine of A plus delta m by 2 by sine of A by 2. Clear? So what you can write it now? Sine of, so A and A, therefore 2 into A by 2 by sine of A by 2. Just now I discussed sine of 2 theta, therefore it will be equal to 2 sine of A by 2 into cos of A by 2 by sine of A by 2. This will get cancelled out now, here n, right? So therefore n is equals to 2 into cos of A by 2 will be your refractive index in terms of angle of prism. Clear? Right? Sometimes they will ask you what will be the angle of prism also, n by 2 into cos inverse of into 2 into, like that you also can write it. Clear? Right? Now we will go for one more question now. Yeah. Right. If refractive index is given as cot of A by 2, find the minimum deviation of the prism. So refractive index how much now? Minimum deviation is asking, no? So you know the formula, refractive index is cot of A by 2, therefore sine of a plus delta m by 2 by sine of a by 2. Cot a by 2 means cos of a by 2 by sine of a by 2. Clear? This will cancel here now. So, this cos can be written as right sine of 90 minus a by 2 sine of therefore a plus dm by 2. Clear? So, therefore, you can rewrite it as 90 minus a by 2 is equals to a by 2 plus delta m by 2. So, this taken here now, taken here. So, 90 minus, so a by 2 means a, so it will be equal to delta m by 2. Delta m is equals to 2 times of 90 minus a. Therefore, 180 minus 2a will be your angle of deviation. Clear? Clear? Just mathematics. Now, we will go for one more question. No? Okay. So, it is a small angled prism. No? Right? Okay. So, now let us see. A small angled prism of 6 degree is made with a material of this one. No? And ray of light is incident as shown onto this one. No? M is the plane mirror. Then find the angle of deviation of the ray reflected from the mirror with respect to the incident ray. So, now therefore, let us see, you try to understand here. No? There is a small angled prism. This is your 90 degree. So, refractive index is given as 1.5. This is your 6 degree, not 60, 6 degree. Now, what happened now? This light ray is incident normal along this one. Now, what happens now? This light ray will go like this. Now, so actually if this is not, therefore this is your normal, then what will happen now? It will bend toward this side. Clear? Now, there is one prism is, one plane mirror. Now, this plane mirror, what it will do now? So, here there is a normal. Now, this is your normal and this it will be get reflected back. Clear? So, now what is asking now? Is asking what will be the deviation now. So, deviation means what will happen now? See here, first of all, I already discussed so many times now in the mirrors and all this, how to calculate the deviation. So, this light ray which went like this much amount of deviation is taken place. Deviation 1, and for reflection, no, for this reflection, no, therefore there will be one more deviation, it will be takes place now. Therefore, this should go on here, no. Therefore, this much amount of deviation is taken place now, delta 2. Clear? So, total deviation can be written as deviation 1 plus deviation 2, but you have to see, therefore, there is a clockwise or anti-clockwise, right. So, this type of concept I already discussed in the plane mirrors. Check it now. This deviation, what will be the formula here? Delta 1 now, deviation 1, n minus 1 into a. N is how much now? 1.5, that means 0.5 into 6 degree. So, that is nothing but 3 degree. Delta 1, I got it as 3 degree. How it is there now? So, it is went like this, it is converted, therefore, it is going in the clockwise. This is your clockwise. Clear? Now, in angle of, in refraction, no? In reflection, no? What will be your angle of deviation now? Delta 2. What is the formula I discussed, no? Therefore, 180 minus 2i. Clear? Understood, no? So, here you can see I, so this totally 180. Therefore, 180 minus 2i. So, what will be the angle here now? This it should be at 3. Therefore, this also compulsory 3 degree. So, this also 3 degree. So, therefore, here what you will get it now? 180 minus 2 into 3 degree. Therefore, 180 minus 6. Therefore, 174 degree clockwise. because here it is went like this, it is rotated. Therefore, it is 3 plus 174, both are clockwise now, 177 degree will be your total angle of deviation in the clockwise. Clear? Right? Yeah, right. Almost we discussed different model questions onto this one. Still, right, if different model questions are mostly more than this one, no, you may not expect it, no. Maybe they may twisted with the angles and onto this one, no. More than this, you cannot expect any questions related to the prism onto this. Clear? So still, if I find some different varieties of questions, no, which is having new logic, so then I will come with one more video for a related to the prism now, right. So right now this is about the prism. So please thank you for watching. Please subscribe to my channel. So through my channel you can learn physics very easily. Those who want to learn the physics, no, so please share to them. Thank you for watching.